So what is it we do? Well, we take a wastewater product, we turn it into high-value minerals. And if we look at the different lithium technologies, well, we can do a rundown and see how they compare to each other. This is hard rock mining, and remember that hard rock mining accounts for about 2/3 of all lithium today. And how it works is that we break the ore, that's what you see in the top right here on the screen, in a huge area, which obviously causes disruptions to nature, to wildlife, and also pollution. Most of this is going on in Australia, and what we then do is we put it on a truck, because this is often in remote areas. We then put it on a ship and we sail it off to China, and then we process it. The process involves calcination, sulfuric acid roasting. Doesn't sound very nice, it is not. Leaching, which is basically using a lot of water. And then finally carbonization and refining. This is a production method with a lot of environmental footprint, and this is also why we get this pushback on the EV adoption. The other production method is brine solar evaporation. This is what predominantly is done in South America. It's about 1/4 of what we do today, lithium mining today. And here we do something different. We find deposits of lithium-rich water. We pump it to the surface. We then mix it with lime. And we then put it into evaporation ponds, which is what we see in the top right. Those evaporation ponds, we leave it for 2 to 3 years, maybe 4 years. The water evaporates, and we take out the lithium. This is not very sustainable either. It causes a lot of disruption to nature. It has a big environmental footprint in terms of pollution of soil and groundwater resources. And this often happens in areas with high water scarcity. And then we have the direct lithium extraction. This is a picture from China, in fact. And this is where most of direct lithium extraction takes place today. They do the same thing. They pump lithium-rich water to the surface, but then they extract it right away in a process that is very similar to what we do. The process doesn't take 3 or 4 years. It takes 2 hours. So you put it through the system and you end up with lithium carbonate that you can now sell. This is a much more sustainable way of doing things. And when we compare things, we can also see that it is much more sustainable. The lithium yield, up to 95% we extract, instead of 20 to 40% by solar evaporation, for example. So it means we use more of the lithium that's actually in the water instead of letting it go to waste. The average footprint, 1.4 acres to produce 1,000 metric tons of lithium versus 115 for hard rock mining. There is very little pollution. Water consumption, just 80 million barrels per 1,000 metric tons of lithium versus 550 million gallons for solar evaporation. CO2 footprint, 1.5 million kilos to produce 1,000 metric tons of lithium carbonate versus, 15 million kilos, 10 times more for hard rock mining. So DLE is clearly a way of making lithium extraction, lithium production much more sustainable. So now it's so great, why don't we just do that? And we do. We do use DLE, but we do it with a different feedstock, and this is what we're going to talk about. We do many of the same things. The slide looks very similar to what we just saw for DLE. But what we do is we take a different feedstock. We take oil and gas wastewater. So it also means that we are not drilling to get water. We take a feedstock that's already on the ground. We co-locate with midstream operators. So it means they already have the pipe system to pump in the water We just take it. This saves us a lot of years. It saves us a lot of money. Because what you would typically do when you want to do a DLE setup, you would go out, you would look for lithium-rich water. You spend some years doing that. You then find it. You acquire the land. You start filing for drilling permits. Maybe that takes 3 years, 4 years, 5 years. And then maybe you can get into production. Again, the average time to bring the lithium operations online is 18 years. By bypassing all of that, we can do new lithium operations in just 18 months. We got our permits for the factories we're planning now in just 6 weeks. Because there's no drilling permits, there's no lengthy time to do that. We can do it very, very quickly. But other than that, we do the exact same things. We take the oil and gas wastewater, we do direct lithium extraction. In fact, we use many of the same technologies. And then we refine it, and then it's ready to go out to the customers. A factory looks like this. This is actually the drawing from our first factory in North Dakota. Produced water comes in. We put it to the pre-treatment separation concentration, which is kind of the secret sauce of what we do. Goes into direct lithium extraction. We do lithium concentration, and then finally refining and calcination, and we got the finished product, which is stored right here. So again, we do everything in one facility. So it also means that we minimize ground transportation. It's good for cost, it's good for the environment. If we then look to how are we different? Well, this is the same slide we saw before, but where we are different is that we only use 20 million gallons of water versus 80 for normal DLE. We're the same footprint. We're carbon neutral because we offset our feedstock against what we do. But the really big difference here is that we can set up a new 1,000 metric ton facility for $18 million. Normal DLE is about $45 million. Solar evaporation, about 50 million. Hard rock mining, about $60 million. So we are significantly cheaper. And it also means less invested capital. It allows us to do more projects. That's super important. But what is also important is we can do it in 18 months, not 18 years. And then finally, we actually also lower cost. We got this idea in 2012 when we did a pilot project with a big oil manufacturer. We discovered there was a lot of lithium in the water. We looked into it back then. There was no way for us to do it economically, so we left it. And before I invested all of my money into this, I wanted to make sure that we had a production method that was quicker, that was more sustainable, but also lower cost. Because what I learned over the years is you can be more sustainable than the rest, but if it's higher cost, nobody wants to pay for it. So I think it's important that we kind of cover all of that.